I'm going to be telling you about radical equations in this section. Radical equations are just equations with radicals in them. You have to solve them by isolating the radical and then squaring both sides to get rid of the radical. This is the only time in the year that I'm really going to insist that you check your answers, because you can have extraneous solutions, which means that they look like they work and everything goes well in the problem, but then when you check it, it doesn't. So you have to check your answers in these problems. So number one, again, remember, we're isolating the radical before we do anything else. So in number one, 5 equals the square root of h over 4. I'm going to multiply both sides by 4. When I do that, I'll get 20 equals the square root of h. To get the h by itself, or to get rid of the radical, you square both sides because it's a square root, so the opposite is to square it. That cancels, and you get 20 squared is 400 equals h. So if I was to plug that back in, for the check, I'll get 5 equals, so this is my check, 5 equals the square root of 400 over 4. The square root of 400 is 20, over 4 is 5. So yes, that works. So my answer is 400. Number two, I'm isolating, so I'm going to subtract this 8 first. So I have the square root of x minus 3 equals 7. I'm going to square both sides to get rid of the radical. I get x minus 3 equals 49. Add 3 to both sides, I get x equals 52. If I plug that back in, so let's do the check, I would get 52 minus 3 plus 8 equals 15. So that's the square root of 49 plus 8 equals 15. 7 plus 8 equals 15, which is true. So that works. Okay, and number 3, the radical is already isolated, so to get rid of it, I'm going to square both sides. So I get 2 minus y equals y squared. Now, anytime we end up with a quadratic term, I want one side to equal 0. So I'm going to add y to both sides and subtract 2 from both sides. When I do that, I'll get 0 equals y squared plus y minus 2. Now, this is a quadratic equation, so I'm going to go ahead and factor. So anytime I end up with a quadratic term, I'm going to have to factor, which brings us back to chapter 8. So what times what gives me y squared, y and y? What times what gives me negative 2? That adds together to give me a positive 1, a positive 2, and a negative 1. So I would set both of those equal to 0 separately and solve for the y. So I get y equals negative 2 and y equals 1. Now, we have to check it, right? So let's check the negative 2 first. So the square root of 2 minus a negative 2 equals negative 2. Well, we get 4. The square root of 4 equals negative 2, which is not true. So this would be an extraneous solution, okay? That's what I was talking to you about. This is why we have to do this, because even right here, it looks completely fine, but when we check it, it did not work. So that is not going to be an answer. Okay, so let's check the 1. We've got 2 minus 1 equals 1. The square root of 1 equals 1, and that is true. So the only answer we have is that y equals 1. Number 4, we want to isolate the radical first. So the first thing that we move is the 2. So since it's plus 2, I'm going to subtract 2 from both sides. So when I do that, I have the square root of x plus 4 equals 3. Square both sides to get rid of that radical. So I have x plus 4 equals 9. Subtract the 4, and I get x equals 5. So that looks good, but let's just go make sure that it works. So we have 5 plus 4 plus 2 equals 5. So that would be the square root of 9. And yes, that's true because 5 does equal 5. So that works. So x equals 5 is my answer. So this is a multi-step problem. So it's 3 squared of x plus 2 plus 4 equals 1. So what number do I move first? Well, the plus 4 is going to be the first thing that I move first because it's farthest away from the variable. So when I do that, I get 3 times the square root of x plus 2 equals negative 3. Then I'm going to have to divide both sides by 3. And I get the square root of x plus 2 equals a negative 1. I can stop you right there and say that this is not, it's going to be a no solution problem. The reason why is because a square root right here can never, ever, ever equal a negative number. Because a negative number times a negative number is always going to be a positive number. So anytime you have a radical equaling a negative number, once it's isolated, it's no solution. Okay, number 6, let's isolate this radical by subtracting 1 from both sides. So I'll get the square root of 2x minus 2 equals x minus 1. Now we have to square both sides. We have to square both total sides. So it's going to look like this. What's going to happen is you get 2x minus 2 equals x minus 1 times x minus 1 because we wrote it twice. Remember, we have to square both sides, so that's what's going to happen. So I get 2x minus 2 equals distribute x squared minus 1x plus 1, or you could do a difference of squares, whichever you choose. 2x minus 2 equals x squared minus 2x plus 1, because I combined both of those. Now I'm going to get like terms together. And since I have a quadratic term, I'm going to set one side equal to 0. So I want to add, or I'm sorry, I want to subtract the 2x and add the 2 to both sides so that I get 0 on that side of the equation. I get x squared minus 4x plus 3. And now you're going to have to factor because you've got a quadratic equation. So 0 equals, what times what gives us x squared? X times x. What multiplies together to give me 3 and adds together to give me a negative 4? Negative 3 and negative 1. You set each of those equal to 0 separately and solve for the x. So I get x equals 3 and x equals 1. But we have to go back and make sure that those work in the check. All right, so we have, let's plug in the 3 first. So we've got 2 times 3 minus 2 plus 1 equals 3. So I've got the square root of 6 minus 2 plus 1 equals 3. So the square root of 4 plus 1 equals 3. 2 plus 1 equals 3. 3 equals 3. So that works. Now, immediately when I see one works, I circle it as the answer. Now let's do the other one. So I'm going to plug in the 1. So I've got the square root of 2 times 1 minus 2 plus 1 equals 1. So the square root of 2 minus 2 is 0. Oops, sorry. Let's see. So 1 equals 1. Yes, that's true. So both of these are my answers. So 1 and 3. And the last problem will be quick. What do? We subtract the 12 from both sides to isolate the radical. And I know you're getting tired of hearing me say isolate the radical, but it's so important. So we get the square root of x minus 3 equals negative 4. Now I know right here that this is going to be no solution problem because you can't have a radical equaling a negative number. But let's just say that I didn't catch that, okay? And let's see what would happen if I continue to work it out. So I know I'm saying right now it's a linear solution, but just saying I didn't catch that, let's see what would happen. If I square both sides, would x minus 3 equals 16. If I added the 3, I would get x equals 19. Now, let's see what happens. If we check it, because you're supposed to, you would get 19 minus 3 plus 12 equals 8. Okay, so this would be the square root of 16 plus 12 equals 8. 4 plus 12 equals 8. That is not true because 16 does not equal 8. So even if you didn't catch it right here, where you have a radical equaling a negative number, your check would show that that is not a solution also.